Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 180. Please turn to page 180. Today is our lesson number 227. Problem number 198 is what we are about to solve. Problem 198, as you read the problem to yourself, you realize that it's a fairly complicated algebra problem. It's an algebra word problem. When you come across a complicated algebra word problem in the exam, you have two choices, as always. One is to solve this problem the way the authors, the test giver, expect you to solve, which is algebraically. In other words, to solve it in a traditional manner, conventional manner, orthodox manner, a very academic way, in a very mathematical way, in a manner that your math teacher will expect you to solve. Other way to solve this problem is to avoid the algebra altogether, and you do that by making up numbers for the variables. The technique is called plugging in. Plugging in. And in plugging in technique, as we said, what we do is we make up numbers for the variables, and we convert, and thereby we convert this algebra problem into a very simple, straightforward arithmetic problem. We get our answer, then we go to the answer choices, we replace all the variables with their appropriate values that we have assigned. It's up to you to assign whatever value that you want to assign for the variable. And then we keep on going through each of the answer choices until we come upon one answer choice that matches, that you arrived at based on your number. Now, having said that, in theory, you could plug in any numbers that you want for variables at all, anything at all. But in practice, there are some numbers that are smarter number, and there are some numbers that are not so much smarter. For example, here, let's pretend that we solved, let's pretend that we solved a total of 100 newspapers. A total of 100 newspapers we're pretending that we're going to sell. So here's our total newspaper. Some of them were newspaper A, some of them were B. Now you might be tempted to say, well, let's pretend that half of them are A and half of them are B. There is nothing wrong with it, except, as I said, some numbers make your calculations more tedious and some numbers are more friendly. For example, here, it's not a big deal to figure out how much money, because we're going to have to figure out how much revenue was generated from newspaper A. We are told that newspaper A was sold for $1. Well, this is very easy. 50 times $1 is just $50. But when we get to B, we're going to have to multiply $1.50 by $1.25 by 50. Well, 50 times 1 is 50, but to figure out how much money is 50 quarters, it's a bit annoying, because 50 is not divisible by 4. Had we had a number which was divisible by 4, had we had a number which were divisible by 4, we would have had much less of a difficulty figuring out how much money it is. For example, if somebody asks you how much money is 40 quarters, well, 40 quarters is very easy. 4 quarters makes $1, so 40 quarters is $10. So that's what I'm going to assume. We're going to assume that we are selling 40 of B and therefore 60 of A. Are you with me so far? Very good. Now let's figure out the revenue. 60 newspaper A will give us $60. This is the revenue. How about B? B, again, since we are selling 40 of them, we just talked about it, 40 newspaper at $1.25 each, that will be $40 plus 40 quarters. $40 and a 40 quarter. 40 quarters make $10. So here, times $1.25 makes a $40 plus 40 quarters. And 40 quarters is $10. So altogether it is, this part is $50. So what is our total revenue? Our total revenue is $110. Our total revenue is 60 plus a 50, $110. What is the question asking? It says our percentage of revenue came from the sale of A. So let's figure out what R works out to be. R would be the share of the revenue that came from A, which is $60 out of a total of 100. 60 over 110 rather, 60 over 110, but that is not a percentage, that's a decimal. That's like writing 0.4. Well, if somebody is asking you how much is percentage, you can't leave it at 0.4, you have to multiply it by 100 to get 40%. Do you understand? If someone asks you what percentage is 3 out of 6, well, 3 out of 6, if you leave it like this, it's just 0.5. You can't just leave it like that, you have to multiply it by 100 because the question is being asked what percentage is 3 out of 6, not what proportion. What proportion is 3 out of 6? 3 is half of 6. What percentage is 3 of 6? Well, it's 50%. Now, how do we get 50? By multiplying by 100. So similarly, here, this is just a decimal. We have to multiply it by 100. This is the percentage of the revenue. Let's make a note here. This represents the percentage of total revenue that came from the sale of newspaper A, and they have given it a name. They have given that this amount, this quantity, a name. They call it R. So that's our R. This is R. Our R equals this. What is the question asking? And how much is P? It says P percentage of the newspaper sold were A. Well, P is this guy right here. P is 60%. We started out by assuming that out of a total of 100 newspaper, we sold 60 of them were A. We started out by assuming that we sold a total of 100 newspaper, of which 60 were newspaper A. So P equals 60. There you go. P equals 60, and R equals 60 over 100. Sorry, 60 over 110 times 100. Express R in terms of P. That's it, we are done. This is our answer. This is our answer, that's it. Problem is done. All we have to do is go through each single one of answer choice. Wherever we see P, we're going to replace with 60 until we find our answer. The question is, we have to express R. This is our R. This is our R. Embedded in it is some value of P. P is 60. You see, there is your P. So P is 60 is just going to be P times 100 over 100. P is 60. It's just going to be P times 100 over 110. In other words, 100P over 110. Do you find any answer choice that says 100P over 110? Well, let's do it out, shall we? It's going to require some work. Let's go through all of them here. There is no answer choice which simply says, see, the P is 60, so it's P times 100 over 110. Now, if they had given us one answer choice, which was simply 100P over 110, we would have been done. But quite unfortunately, they do not. So we just got to do some work. Let's do it over here. I'm taking it too slowly and it's taking too long. I don't want to give you the impression that this technique takes too long. Actually, this is a very fast technique. It's taking a little bit longer because I'm going too slowly. Answer choice A says 100P times over 125P. Let's find out. 100P would be 100 times 60. 100 times 60. So far so good. We do have 100 times 60 on the top. Over 125 minus P. 125 minus 60 is not going to give us 110. We need 110 at the bottom. 125 minus 60 is not 110. Answer is not A. Let's look at B. B says 150P over 250 minus P. Again, there are several problems with this. First of all, it is 150 times P on the top. We need 100 times P. Secondly, 250 minus 60. 250 minus 60. 60 is our P. Remember, P is our 60. 250 minus 60 does not equal 110, does it? No. Answer is not B. Let's look at C. So yes, in theory, you do have to go through every single answer choice to see which one matches your answer. But in practice, the process is process goes faster because a lot of the times you can simply tell by looking at it. You don't actually have to do it out everything. C says 300 times 60. What the hell? 300 times 60? We don't have 300 times 60. We have 100 times 60. 100 times 60. That's one problem with it. Another problem that you can immediately see is 375 minus 60 does not equal 110. Now the reason I'm doing the bottom part, even though the top part does not match, is because one never knows. Maybe the bottom part has some times 3 something. If the bottom were 3 times something, then we could have cancelled out this 300 with a 3, and it would have become 100. So you have to look at the bottom. The bottom does not have, it's 375 times 60. It's not going to work out. It's not going to work out. Let's look at D. D says, so we're done with A, B, and C. Answer is not A, B, or C. D says 400 times P. You see, it's 400 times P. We need 100 times P, but we're going to keep on going anyway, just in case if we can find a factor of 4 at the bottom, we can cancel out the top and the bottom by 4. It says 500 minus P. 500 minus P. 500 minus P would be 440. Aha! 440, on the top we have 400, in the bottom we have 440. Why do we multiply the top and the bottom by 4? You see? You multiply the top by 4, 400 becomes 100, giving us 100 times 60 on the top that we need here, giving us 100 times 60 that we need here, and the bottom, if you divide by 4, it becomes 110, which is precisely what we need at the bottom. Voila. There is your answer. That is our R. Our R equals 60 times 100 over 110. That is exactly what the D gives us. Answer is D. And just to satisfy your curiosity, I will show you that E does not work. E says 500 times 60 over 625 minus 60. It's not going to work. It's not going to work. The answer is D. Alright? So that's how you do it. Plugging in technique. Don't try to solve this problem with algebra. If you try to do it algebraically, you will find that it is a nightmare. There is a time limit on the exam. Time is of the essence. The key here, the name of the game is to keep moving. Nobody's going to be impressed by how much algebra you know. The computer does not care about it. They just want you to check mark the right answer. Do you understand? I know it's a cynical view, but unfortunately, one has to be pragmatic. Okay. I'll see you tomorrow, okay? Bye now.